Hello, my lovelies. So we're going to take a dive into some of the early stuff from 6A, characterizing data. So these should be familiar. So I'm going to treat this kind of as like a review of what these words mean. No pun intended, totally. So the distribution of a variable refers to the way its values are spread over all possible values. We can display a distribution with a table or graph. So what we're really going to focus on here is measures of center in a distribution, or measures of central tendency is what it's sometimes called, or what I might say. So I thought this graphic from the book was really cool, but those are the values of blocks. If this was a frequency histogram, the mean is where you would put the balance point so that the weights would be the same. So the number on the left would be the same as the number on the right. Now that's not totally true because technically there's like torque involved, so still, I like the idea. All right, so the three things that we are going to look at. We have mean, median, and mode. And these three words trip people up. It's the which is what, huh? So I came up with a kind of mnemonic device to help with it. So the mean is the meanest calculation of the three, because it's the average. You got to add everything up and then divide by the number of values. That's a lot of work. Not difficult work, but comparatively, it's a lot. Now the median, hold on, let me spell that the way I do. The M and the D capitalized is the middle value. Once the data is sorted, ordered. So you start with the smallest value and you keep repeats if they happen, but you basically take whatever the list was and rearrange it so it's smallest to largest. And then like one way to do it is to like put your fingers on the start and the end and just kind of tick off values as you get closer and closer to the middle. If you actually have a spreadsheet, you can see how long the list is by looking at the cell numbers, figure out the halfway mark, and go find that cell. Now the last one is the mode. And the mode is the most frequent. I sometimes think of it as the most peculiar. So the most frequent is if a value shows up more times than anything else. So because of this, we can have ties. So there can be multiple modes, one mode, or no mode. If everything has the same frequency, then there's no mode. Now, normally, everything having the same frequency means that there's one of everything, but technically, if I had a bunch of data that was pairs of the same thing, then we would say it does not have a mode, at least according to this book's definition. Some people actually sometimes kind of change just depending on the book you're dealing with. So that's one of the reasons why statistics is so damn confusing. All right. Now we have this other interesting idea, and that is an outlier. So an outlier in a data set is a data value that is much higher or much lower than almost all other values. And an outlier can change the mean of a data set but generally does not affect the median or the mode. So it's still going to be counted when you count your values to get to the middle, but it being really, really high or really, really low isn't going to affect where the middle value falls. Like, you know, it might be one way or the other, but that middle will still be true to the real middle. The mean, though, when you have an outlier, depending on how much of an outlier it is, it can seriously drag the mean up. All right. The book had a funny example for this. It was one particular school averaged all of their geography majors' salaries together, and they got a ridiculous number. And the reason the number was ridiculous is because they happened to have Michael Jordan as a geography major, and they were using his NBA salary. So his value dragged everything way up high for the mean. So he was very much an outlier in that measure, but, you know, kind of funny. Didn't know he was a geography major. If you don't know who Michael Jordan is, not Michael B. Jordan. Michael, like Air Jordan, Chicago Bulls basketball, when most of you guys were not even born. Oh, I'm old. All right. So we're just going to talk about those two examples in the table, and that will be it. All right, so the existence thing here is nice to see. So there is always a mean, there is always a median, because here we are talking about numbers, not qualitative where it's like red, red, yellow, green, blue. No, these are numbers. So there's always an average of the numbers. There's one number, it is the average. Median, there's always a middle value. Even if we have an even number of sets, we average the two middlemost. And then the mode is the most frequent, and that one is not always used, like not always in existence. There could be none, there could be one, there could be more than one. So affected by outliers. The mean is, the median and the mode are not. So the mean, especially when you have really large data sets, the mean and the median actually end up being like nearly the same, unless you have really crazy outliers. And then the mode is not used as frequently because it just depends on the data set. Sometimes the mode is useful to know, but other times, like, it isn't even there, so it's not used. So here we're going to be comparing mean versus median for example 2, and then we have two different means that are both correct, and we have to figure out why. All right, so let's hide that one. A track coach wants to determine an appropriate heart rate for her athletes during their workouts. She chooses 5 of her best runners, that's a convenience and biased sample, and asks them to wear heart rate monitors during a workout. In the middle of the workout, she reads the following heart rates for the 5 athletes: 130, 135, 140, 145, 325. Which is a better measure of the average in this case, the mean or the median? Okay, so heart rate is beats per minute. It's like 120, you know, they're doing exercise, so it should be higher. So 130 up to 145, sure. 325 and your heart is splat. So if I did the actual average of these, that 325 is going to pull the average higher than those other 4 values. And since it's over 100 higher, it's going to pull it by a good amount. And so the average here is not going to be a good representation of what the middle is. So here, taking the median would be better because we have that 325, which is very likely a glitch on the system. The runner does not have a heartbeat of 325 beats per minute, they would die. So it's a glitch. So taking the median will ignore that outlier. And 140 is the median here, and that is much truer to the bulk of the data. All right, so median, because it can ignore the outlier. That is 325, which is obviously a typo, not a typo. Granted, that could happen, but here it's a flaw in the system more than likely. Here. The mean would be, let me say, dragged higher by this outlier. All right, so mean versus median. When you have outliers, median is the better, like the more true representation. If there's no outliers, mean and median are going to be about the same. Unless the data is skewed, then they'll be a little off. Which mean all 100 first-year students at a small college take 3 courses in the core studies program. 2 courses are taught in large lectures with all 100 students in a single class. The 3rd course is taught in 10 classes of 10 students each. Students and administrators get into an argument about whether classes are too large. The students claim that the mean size of their core studies classes is 70. The administrators claim that the mean class size is only 25 students. Can both sides be right? Explain. So we're seeing 70 is the stated mean size of the class, and 25 is the mean size of the class. So what we have to figure out is how we can get those numbers from the calculation. Now, if you were thinking about this in your head already, you probably arrived at one of those 2 numbers. And since we are students, the student one is probably, it's easier to put yourself in the shoes of the student than the administrator. So the student takes 3 classes of size 100, 100, and 10. So the student looking at his schedule or her schedule, their schedule, I got 2 big classrooms and the one with only 10, 210 divided by 3, that is an average of 70. So how in the world did the administrator get 25? All right, so kind of take a step back. As an administrator, I'm probably looking at the schedule, the giant schedule of all that is being taught. Luckily, it's a small college, so it's not too long. So I've got the first 2 large lectures, and then I have 10 classes of 10 students each. So the administrator pulls up the list of classes and sees 12 classes. So 10 have 10 students, and 2 have 100 students. So that is actually 300 students over 12 classes, which 300 divided by 12 is 100 divided by 4, which is 25, which is what the administrator says. So the administrator was averaging all the classes, the student was averaging what they took. So strangely, both sides can be right, and this is why statistics are oh so hated. One of many reasons. All right. So we talked about mean, median, and mode. Feel free to ask me to work some examples. The rest of the semester is like just work examples for the lecture you're seeing in the other class. All right.